Hello everybody, I'm Gleb and this lesson about 5G security aspects. This is a lesson about some basic stuff. So let's start with terminology. What does it mean, accessibility? Basically it means that the system is accessible for our usage, so you can access the system without any problems. Let's suppose that we have a very strong interference in uplink channel. In this case, the system would be inaccessible for such operations, for getting any resources. Availability, this is the ability to secure storage, transferring, the ability to keep connection for needed time, yes? So the ability to utilize resources. This is availability. It's after accessibility. Integrity. Integrity, it means that the attacker cannot modify the message, the information inside message without receiver noticing it, without, let's say, user equipment noticing such changes. So this is integrity, and it has connection to authentication. Authentication, this is the process of proof of, it is when user equipment wants to prove network that this is the true network, there is no face-based, false base stations, yes? And the network can try to prove user equipment that this is a legitimate user equipment with a real, true SIM card or integrated card, yes? So this is authentication. What does it mean, personal data? Actually, this is any data which may help attacker identify someone, to understand that yes, this is that person, or yes, this is that device. Sensitive data, it is any piece of data that can harm confidentiality, that can connect, that may have connected to confidential information. And should be secure for that reason. Okay, so let's start with a brief overview of resilience. What is improved in 5G network when it comes to radio network? Of course, the separation, the split inside base station into central unit and distributed units, it can help to improve our security. Why? How it can be? Basically, any security operations is inside central unit, and central unit we can locate in much more secure location in some local data centers, let's say so. And distributed units, this is just not, let's say so, very smart part of network. Distributed units can be just spread over the city and responsible for radio signaling, for generating signal, for beamforming and other stuff, yes? So central unit is basically can be located somewhere in secure location, and the amount of central units is much more lower than distributed units. This is also very important. Next is URLC technologies. So what does it mean? It means that we can using very advanced scheduling techniques, using packet duplication on PDCP layer, using other technologies that can relate to URLC, we can improve not only latency but also the resilience of our channel. The same we can say about dual connectivity. Yes, when our user equipment works at the same time with 4G network and with 5G network. It basically improve the coverage, improve the resilience of channel. But there is a very important point should be here. We all know that in 5G 5G has some improvements, yes, in terms of security. And if we want to use these security improvements in dual connectivity mode, we should work with such modes when 5G base station is master node and we connect it to 5G core. So only in this case we can gain all 5G security benefits for our connection, for security information. So this is not basically the case of non-standalone operation mode 3, yes, option 3. This is not the case. In option 3, everything is related to 4G network. 4G base station is master node in this case. In option 3, 4G core network is our main core, and in this case there is no difference. Beamforming. Well, I think why not low physical layer cannot be considered as improvement for security. I think this is one of the main improvement, because using beamforming we can generate very narrow beams toward particular user, and it would be very difficult for attacker to identify the location of that user and to eavesdrop to listen such channel, yes, because you don't know exactly which beam to track that user and in which location, because such antenna system radiates only in particular locations, not in multiple directions. So let's talk about resilience for core network. For core network, of course, we can consider as improvement is separation of compute functions and store function. What does it mean? It means that if compute function is down, if something wrong with our core network or attacker here, if compute function is down, every necessary information is still keeping in storage separation, in storage function, and we can recover that information very fast, yes, when our compute function is already work. So the next step is network slicing. Basically, network slicing is not only about improvements and improvements in terms of services, yes. This is also the isolation. This is also the implementation of different security aspects for every slice. So we can isolate our traffic from other traffic, and it can be also the case for security. And basically 5G core network is based on service-based architecture. This is the new architecture, and it means that we use virtual machines. It means that we have separation between hardware and software, yes, and if some network functions is down, we can use available resources for up this network function very fast without any big troubles and problems as it was in previous core networks. And right now let's talk about other aspects of 5G security. Let's start with access stratum security. We can see that 5G can support User plane integrity protection. What does it mean? It means that right now we can use ciphering for a user plane, and it can very drastically improve the security, especially comparing with previous networks, with 4G network, when we didn't have such option. This user plane protection can be optional in order to allow less complex users to access network, and to lower the complexity and the cost of equipment. This regulates from core network, from core part, and SMF actually decides such protection. SMF can have such options as user plane integrity protection can be required, it can be preferred, and it can be not needed. So 3 different options for more advanced operations. When it comes to decoupling, we know that in 5G we have more advanced decoupling of control plane and user plane, and actually we can manage security operations in a different way for control plane and user plane. For example, integrity protection, we can deactivate or activate for user plane, but for control plane is still available. Yes? Fast synchronization, it means that for some cases, for some handover cases, for example, synchronization of access stratum and non-access stratum messages, such context may be much more faster, and it means secure in this case. When it comes to non-access stratum security, I would like to mention such kind of a new feature as home stratum, let's say so. Home stratum is when access stratum user equipment can have with roaming network, yes, but non-access stratum operate with home PLMN. So it means that access stratum operates with roaming network, with local network, yes, but non-access stratum operations and all security aspects is still with our home network, more reliable network, more trusted network, let's say so. Key separation and key management. When it comes to key separation, it means that for example, in previous network, in 4G network, MME usually inherit the key from previous MME when user equipment make handovers between different mobile entities, I mean MME nodes, yes, so it inherits, but in this case we can define separate keys for access and mobility function for AMF nodes, and such key can be refreshed with more, let's say so, faster and manageable in a more effective way. Anti-beating down techniques. We will talk about it later as well, but I would like to mention it because in previous network it was possible to get user equipment capability. Yeah, attacker may do so and try to send commands for a real user equipment to down to 3G to 4G network, when it's much more easier to hack the device and the eavesdrop, listen the channel, let's say so, or read short messages. And what's more interesting related to non-access stratum is multi-NAS connections. It means that we can have multiple different non-access stratum connections. one for 3GPP network, another for non-3GPP, for Wi-Fi networks, let's say so. When it comes to front haul and backhaul security, when it comes to radio interfaces, I mean interfaces in a radio network, yes, we can see that X1, F1, N2, N3 interfaces, they can support IPsec for such security and DTLS protocol over SCTP. As far as I know, this is a new feature. Actually, I'm not an expert in security protocols, so as far as I know, that DTLS is more friendly for virtualization, so that's why DTLS can be used in 5G case. When it comes to interconnect between different core network, between different operators, we can use this special node, it's called SEP, exposure, security exposure function. It can be used for protecting N32 interface, this is interface between two core networks. And the same story, actually the same kind of the same gateway, security gateway, can be used with IPsec for N2 interface, for interface between different UPF. So this is improvements in 5G core, in 5G RAN network interfaces. And right now let's talk about attacks, types of attacks. False base station, using false base station, we can get user equipment capabilities and understand what is the device. This is tablet, this is phone, this is vending machine or Video X device, automotive car, let's say, and use this information with multiple purposes for improving targeting, advertisements, yes, or in some very bad cases. Also, from user capabilities, we can get the information about radio capabilities of devices, such as frequency bands, carrier aggregation techniques, what else, MIMO techniques, and we can give the false commands to switch off such capabilities, and it will definitely has a negative impact on user experience. So we can just make user experience lower, and of course this can be as a type of attack. The next is battery drain. To have a connection to our user equipment and constantly sending and receiving information from that user equipment. So we can drain battery very fast. These can be intentionally or unintentional. In case of intentions, when attacker have some intentions, it has negative impacts on such devices as narrowband IoT devices, which has limited batteries, which supposed to work for multiple years, yes, but in case of battery drain, attacker can reduce the lifetime of battery, and of course this is a negative side. Beating down attack, it is when false base station give commands to user equipment to go from secure 5G network to less secure 4G network, and even to go to 3G to 4G network, to hack voice, to hack short messages. This is extremely very important to know and understand that this is possible, but in 5G we can use the system for paging, for signaling, use only temporary identifications. In 4G, for initial access, it was possible to use IMSI, the identifier of subscriber, yes? But in 5G, we don't use SUPI. Yes, we don't use SUPI for multiple reasons. Instead of SUPI, we use SUCI, which is encrypted version of SUPI, and over radio interface is transmitted only SUCI identifier. And this SUCI is refreshed for certain times, and this refreshment is mandatory in 5G network. In 4G network, TMC was temporary identifier, yes, and a refreshment of TMC was not mandatory. But in 5G, this is a mandatory feature. And one possible vector of attack is when we talk about third parties. If we're talking about some aspects related to private networks, yes, when we can use core network which was provided by third parties such as Amazon, Microsoft, and other cloud providers. In this case, the question is trust. Do you trust to such third parties? Is it satisfy your requirements? It is satisfied to your agreements between users and you and third parties. So this is actually the question of trust, the question of agreements, regulations, and requirements, because in some countries it is prohibited to use third-party core network for communications for private networks. If we are talking about the communication, yes, in a pure definition. So what else I would like to talk is NESAS. NESAS, this is kind of a special organization which consists of 3GPP actions and GSMA actions. So these two organizations, they decided to have a special organization, let's say so, NESAS. Yeah, the main aims of such NESAS organizations is to meet expectation of national security, to be sure that vendor do not have any backdoors for mobile operators. So mobile operator can be sure that if your vendor goes through all requirements and goes through all test cases and audition and infrastructure rules, yes, which is regulated by NESAS, by GSMA. In this case, your vendor is secure, there is no backdoors, and you can rely on rely on that vendor. This is especially the case of Open Run, when we're talking about multiple vendors for core network, for radio network. And of course, it would be good for private network to justify that there is no backdoors from some vendors. So it was my short lesson about 5G security. Of course, all of these improvements, improvements that we've already told and discussed, it doesn't matter anything if your password is 12345. Yes, so we should also take care about the awareness of users to use more secure passwords, to use VPN services if it's possible, if it's necessary, to access only trusted networks. So only in this case, when we have awareness of users, when we have very secure application side, when we have secured user equipment and 5G core and radio network security improvements. Only in this case we can gain the full benefits of 5G, because 5G becomes very critical infrastructure. This is a single platform for everything, for roads, for electricity, for smart city cases, for video X cases, and this is very important to be secure in such fields. So stand by with IoT Understanding channel. Goodbye.